Folks, in this video we're going to talk about sine and cosine, which are two of the trigonometric periodic cyclical functions. So here's where these guys come from. They're non-algebraic, so it requires a little more than just the four algebraic operations. And what we're going to do is we're going to start right here in the unit circle with radius 1. So that's 1, 0, and that's 0, 1. This guy right here is negative 1, 0, and that is 0, negative 1. So now what I'm going to do is I'm going to create this little piece there of length 1, and I'm going to rotate that. And the magnitude of rotation, we'll call that theta, and we're going to call theta in either radians or degrees. We're going to use radians, always in calculus. We'll get into that later, but the conversion is pi radians. It is 180 degrees. Okay. So in any event, we're going to rotate this guy of length 1. And the point at which we land is called the terminal point. Right? And the x value of that point is the cosine of the angle that got me there. The y value is the sine of the angle that got me there. Okay? Very similar to, or the same as this guy being the cosine, the base of that right triangle, and this height being the sine of that angle. Okay? So that said, that's where we start with a cosine and sine. They act upon thetas, angles, which are in radians real numbers, pi radians being 180 degrees. Right, so if we look at an example of this, very basic example, when is the sine equal to 0? For what values of theta? So based on what we just went through quickly, sine is the y value of our terminal point. 0, 0, 0, 1, negative 1, 0, and 0, negative 1. Right? So if I begin here, in the initial position, I want to end at a point which has a 0, y value. And so those y values are 0 here and here. Right? So any angle of rotation about the origin that will bonk me at one of these two terminal points will have a sine value of 0. So of course, one answer is to not go anywhere else, so 0. Right? Don't rotate that at all. Sine is 0. Another solution would be a full half turn, which would bonk me at the terminal point. Of course, that's 180 degrees, but we're talking radians, so it's going to be pi radians. Okay, another solution would be a full 360 degrees full turn, which would wind me up. Bam, right back where I started with 2 pi radians. Dot, dot, dot. And of course we can go in the other direction as well. Dot, dot, dot. Okay, so those are the zeros of the sine. Zeros of the cosine. Are going to be values that, so let's get to the next one. Let's try again. Zero of the cosine are going to be values that land us either at this point, which has a 0 x value, or this point, which also has a 0 x value. Okay. Of course, if we start here, resting peacefully on the x-axis, the unit circle, that's 90 degrees or pi over 2 radians. Get around here, that's 3/4 of a turn, or 270 degrees, or 3 pi over 2 radians, dot, 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 dot. Okay, so those are the zeros of cosine and sine. I found a nice little interactive website that shows me how we take these unit circle values and translate it into the graphs of those two functions now. So here is, actually I'm going to show you the coordinates. Many of you may be familiar with this. Here's 0, 0, and that coordinates or translates to this point right here, the origin. So the red is the graph of the sine of an angle, the blue is the graph of the cosine, and the green is the graph of the tangent of an angle, which is a ratio of sine and cosine. All right, so here we go. We're going to start at 0, 0. So the sine of 0, excuse me, start at 1, 0. The sine of 0 is 0. The y value, the sine of, cosine of 0 is 1. That's why cosine starts up here at 0, 1. The sine goes through the origin. Okay, if I work over to pi over 6, you can see how those points right there, root 3 over 2, correspond with the cosine sine. And again, moving forward, here we're at pi over 2 radians, 90 degrees. Okay, we have a undefined tangent. Okay, and I can, of course, rotate through second quadrant, third quadrant, and fourth quadrant, right? Okay, these are called periodic or cyclical functions because after that 2 pi rotation, it repeats itself. It's the same values. Okay, and you may recall words like period and frequency, amplitude, etc., etc. We'll get those later. Okay, so here I'm seeing the values on the unit circle. There's 5 pi over 6. So the sine of 5 pi over 6 is 1/2. Cosine is negative root 3 over 2. Okay, so you see on the graph 5 pi over 6 and the corresponding sine and cosine values. Okay, so this is just a nice little interactive applet. It shows you how you get from the unit circle to the graph of the sine and cosine. Thanks for listening. We'll talk about this tomorrow in class.